Hey everyone, and welcome. Today we're going to pull back the curtain on the world of educational research. And look, this isn't about dry, dusty old books. It's really an active quest, a journey to figure out what actually works when it comes to teaching and learning. It all boils down to this one simple but huge question. Seriously, think about it. Every new teaching strategy, every curriculum update, every single educational policy, how do we know if it's genuinely helping our kids, or are we just, guessing? This is exactly why we need a systematic way to find the answers. It's absolutely crucial. And that's precisely what educational research is all about. It's not some stuffy academic thing. Nope. It's a quest for knowledge, done in a really systematic way. We get to be detectives in the classroom, figuring out the why, the how, and maybe most importantly, what's next, so we can keep making learning better and better. Now, to guide us on this quest, we need a tool we can trust, kind of like a scientific compass. And that tool is the scientific method. It's the solid foundation that makes sure our journey leads to a real discovery, and we don't just end up lost in the woods. This quote from Carl Pearson just nails it, doesn't it? It basically says it doesn't matter if you're studying planets or plants or pupils. The real power, the thing that makes research legit, is the method you use, not the subject you're studying. So let's dig into what the scientific method really is. At its core, it's just a structured way of thinking. It's all about chasing down the truth using logic. It's a process of connecting the dots, all the facts, through careful observation, smart experiments, and solid arguments, until you have a clear, coherent picture of what's going on. And this whole process is built on 4 critical pillars that make sure we can trust the findings. First, you've got validity. Is your reading test actually testing reading, or is it just a glorified vocabulary quiz? Next is reliability. If you give the same kid the same test a week later, are you going to get pretty much the same score? Then there's repeatability. This one's huge. If another researcher follows your exact recipe, can they bake the same cake? That's key for building confidence. And finally, objectivity. This means the results are about the data, not about what the researcher wished the data would say. So before a researcher even thinks about collecting data, they've got to make some really big choices up front. These decisions are kind of like picking a trail at the start of a hike. They set the direction for the entire journey. The first major choice is about the lens you're going to use to see the world. Are you going quantitative? That means you're all about the numbers, the stats, answering questions like how many students passed. Or are you going qualitative? This is about the story behind the numbers, using things like interviews to answer questions like, why did so many students struggle with that one concept? The next decision is all about your purpose. Is your goal fundamental research, building those big picture theories about how the brain learns? Or is it applied research, which is laser focused on solving a specific problem right here, right now? Like, how do we get attendance up in our school this semester? Both are totally essential to pushing education forward. All right, so you've picked your path. Now you need a detailed map and the right set of tools. In the research world, we call this the research design. It is literally the blueprint for the entire investigation. A really solid research design is incredibly detailed. It spells out exactly where you're getting your information, the step-by-step plan for collecting and analyzing it, and even the practical stuff, like how long it's going to take and how much it's going to cost. Honestly, without a good design, a study can go off the rails fast. And these choices lead to 2 major strategies. On one side, you have exploratory research. This is super flexible, very open-ended. Think of it like you're scouting out new territory to get some initial ideas. On the other side, you've got hypothesis testing research. This is the opposite. It's rigid, totally pre-planned, and it's designed to test a very specific idea, like, does this new app cause math scores to go up? And the gold standard for testing a hypothesis like that is usually an experiment. So here's a classic setup. First, you randomly pick a bunch of students. Then, and this part's key, you randomly assign them to one of 2 groups. The experimental group gets the special treatment, like the new teaching method. The control group just keeps doing things the old way. After some time, you measure the results for both. If the experimental group did way better, then bam, you have really strong evidence that your new method actually works. It's that randomization that makes it a fair fight. So after all this work, the planning, the data, the analysis, where are we trying to go? What's the final destination? What's the treasure we're hoping to bring back from this whole quest? It really comes down to one of 3 things. Sometimes it's straight up problem solving, finding a better way to teach kids fractions. Simple as that. Other times, it's theory building, creating a big, comprehensive model that explains the whole process of how we learn to read. And a third goal is prediction, using what we've learned to forecast which students might be at risk so we can step in and help them before they stumble.
When you really stop and think about it, everything we do in education, every single textbook, every policy, every brilliant strategy your favorite teacher ever used, it all started as a research question. It began because someone, somewhere, wondered, is there a better way? So the real takeaway here is that this quest for knowledge isn't just for academics, it's for all of us. So I'll leave you with this. What question will you ask next?